So we are going to do some computing basic statistics in R, okay? So we will assume we have some X and Y vectors in here, and we can just find the mean of the X. Let's say X is a vector, and we can just find the median of X. Can you guess what this can be, SD? Huh?
Standard deviation.
Standard deviation.
Perfect. Yes, that's the standard deviation, the variance. And also we can just find the correlation between X and Y. Let's assume X and Y's are your vectors. And also, let's say we can just find covariance between them, okay? R can easily give you these guys. For example, I have my fifth vector, again, 1, 1, 2, 3, 5, 8, what was next? 21, 34, 55, 89. This is my Fibonacci vector. You can easily see your vector in here. If you want to see the mean value for this Fibonacci, then just write mean, and here is the mean for Fibonacci in here, okay? And we can easily get the median of my vector, and I just write median or standard deviation. Here is the standard deviation for that guy. And the variance of my fifth vector, okay? And I think we get this 4, 1. And let's generate one more vector to find the correlation and covariance between them. And let's say here's beef. So creative. And get the square of fib. And when you just check out for beef, you will see this is another vector. And if you want to find the correlation, just use core function in R. And when you type that guy, you will see some explanation on this window popping when you type core. And let's core, fib, and beef. You see? Of course, there are really great correlation between these two guys because one of them is the square of the second one. And when you just check out for the covariance between them, you see that beef and fib. And then here is the covariance between them. Are you guys with me right now? Is it clear?
Yes.
Yes, Professor, it's good.
Perfect. So please remember, we generated a V1 vector, which is the sequence from 1 to 5. And also we have this V2 going from 10 to 15. We have two vectors, and we are able to get the mean of V1. Here is the mean. And if you recenter your vector, you can just write V1 minus mean of your vector. And with this algebra, you are just recentering your vector, okay? And there is only one thing that we should be careful if we have some NA values, okay? Which is, let's say, I'm generating one more vector with fib and adding one NA value in here. And you see, I have my Fibonacci or another vector, but just including one more value, an E1, which is NA. And if you get mean, if you try to get mean of this fib, you will see that you are not able to get the mean or, for example, standard deviation for this one, since these functions are really picky about the values that are not available. So NA means not available. If you have any value in your vector which is not available, then R is not able to find the mean of standard deviation of median or of your vector in here. But of course, there is one thing that you can solve this problem in here. For example, you have mean, your fib. If you add another option and say, R, please remove NA values for me. Okay, just open this option, just say true. NA remove is true. And after that, R is going to remove every NA values in your data. Then just for the rest of your data, it's going to give you a mean value. Okay. This is true for many functions. You can use this NA remove for many functions. And so if you have a data frame, for example, we will see it later on. R will calculate their statistics for each column individually. Okay. Then if you have any NA value in here, also you will have some options to remove these LA values by using the NA remove options in here. Any question? And you can also use some tab function in R. I mean the tab in R. And for example, I have my fib. If I write just phi I, and if I say fib, and R is going to find me the fib in here. Okay, I'm generally using fib tab in here. Let's say I have me A. If I say tab, it's just giving me me. Okay. So if you don't know the name of an R function, you can just try guessing the first 2 or 3 letters and just press tab. And if you just guess correctly in here, then the function you are looking for is going to appear in there as a pop-up, okay? This is another way, the shortcut for you guys. So we are going to move to sequence if you don't have any question. So do you know what is sequence? Do you remember what is happening?
There is a question in the chat part.
Okay. So we have another question in chat. Can I also meaning this like? Yes, and we will see about it, okay? So after we see some indexing in there, we will able to remove anything we want. Ayşegül, okay? And sure. So when we go back to sequence, if you do not remember what was happening in there, for example, if you say N to M, what is that? In here, R is creating you a sequence, let's say, from N plus 1, N plus 2, blah, 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 to M, okay? This is what is happening in R when you just write N to M. Let's say if I say 1 to 10, R is giving me 10 numbers in here. Or I can just play with this, I can just use sequence in here. Let's say I use sequence, and if I say 1 to 10, okay? This time we are just using comma, please keep in mind that, okay? And now you can just go from, sorry guys, 1 to 10 by 2. And this is 1, 3, 5, 7, and 9. Okay. Actually, you are saying that in sequence you have from
Professor.
by 2. Yes.
Yeah, I'm just making sure. Do you need to write by? Because I was trying get like
No.
I'm writing the code at the same time and I just wrote 2 and it worked. So you don't need to write by, yeah.
No, no, no. You don't. You can just skip that arguments. If you want
Yeah, okay.
someone to read your script, maybe it can be helpful for them. But for yourself, no. I knows what to put in there. For many.
Okay.
For example,
okay.
let's go back to Ahmad's question. 110 by 2 means 110, okay? Or I can just say sequence 1, let's say 100 by 20. And now it's going from 1 to 100 by 20 in here. And there is also another fancy function in here we can use, is repeat, and which is really helpful in here. We can use rep for repeat, and it says that rep replicates the values in X, and it's another generic function. And let's say I'm going to use rep from 1. I'm going to repeat 1, let's say, times 10. So instead of writing 10 times, you can just use rep in here, or rep 1, 10. Okay, rep 100, 1 million times. Lots of 1 million in here. Okay. And also with sequence, you can just use them backward, let's say from 10 to 0. And you see the result is going from 10 to 0. It can easily go backward. Or for sequence, you don't have to start from 1. You can just start by any number, 10 to 20. So if you don't give any more options, let's say like 10 to 20 by 2, it's just giving you 1 by 1, okay? This is the default. This is the one you are giving some more options or arguments in here. Also, I can just write another vector from 3.5 to 9.5. Let's write it. And you see that it's going from 3.5 to 9.5 by 1. Is it clear in here? Yes, I can hear you. It's also
Yes, hocam.
it's also
It's clear, Professor. Thank you.
And it's also possible to specify some length for the output of your sequence, guy. Let's say, guys,
Hocam bir şey sorabilir miyim?
sure.
Hani 0'dan 10'a kadar yaparken 2 nokta üst üste koyuyoruz ya. 0, 2 nokta üst üste 10. Peki 0 yazmayıp direkt 2 nokta üst üste 10 yazsak baştan 10'a kadar yazdırır mı yine program?
The question is this one?
Yes.
So you don't have the complete arguments in here, so it's not possible.
Tamam, teşekkür ederim.
You're welcome. Sure. So she's asking that if it is possible starting just without 0, and no, it's not possible here. You have to write 0, or if you want to start from 1, you have to write 1, okay? You should give the starting and the final value in here.
Tamam hocam.
Okay. Thank you for the question. What else? And also you can give the length for the output. For example, let's start by using sequence in here. We are starting from 0 and to, let's say, 100. And if you just give that option, which is length out, if you say 5, it's just giving you 5 numbers between 0 and 100 with equal intervals, okay? And you can always easily give some length out, and for your sequence, this is another option in here. And if you are more curious about what's happening in sequence, please write this help, ask R, and see what options do you have in here. Okay, and some examples at the end. Of course, we can also generate some sequences with fractional increments in here. Let's say what I'm talking about. Let's have a sequence starting from 1 and going to 2. And if you add this length out, let's say 5, and you see some fractional increments in here. 1, 1.25, 1.5, 1.75. Okay. And if you want to exit R, I think we haven't used it so far. Make sure, please make sure you saved your R file, .r file. My file name is STAT291.r. Please Control S. Let's say you write something. Please Control S first, then you will see the color will be black. That means you save your work in here, and try not to save your workspace. You don't want to save this workspace unless you want to overwrite the previously saved workspace in here. Okay, and you can just quit R by using this guy in here, or just Control C just to quit R, or exit R in here. Right now, we will start comparing some vectors or compare these the operators we are going to use right now can perform an element by element comparisons of two vectors or a vectors of an element against a scalar. And so you will see the results as logical vectors in logical values in here, like true or false, in which each value is the result of one element-wise comparisons in here. So what I mean is that, let's say I have A equals 3, and you already know what is pi in R, it's 3.14 something. And if you want to say if A is equal, I'm sorry guys, if A is equals pi, and right now you are just checking for equality, and R is saying that if it says false, that means no, A is not equal to pi in here, okay? And if you want to test for inequality, let's say A, and this sign is used for inequality in here. And if you say A is not equals to pi, and that means you are testing for inequality in here. And yes, it is true. A is not equals to pi in here. Okay. And you can also try some smaller and greater signs in here. Let's say A is greater than pi. What is the result? Or I mean, A is smaller than pi. What is the result in here? Huh?
True.
That's true. And if you say A is greater than pi, this is false. Okay. You may want to say A is smaller than equals pi. And we have true in here. And if you say A is greater than and equals to pi, and we have false in here. And when you just write B, which is 3 pi and 4, this is my B. And let's say I have another vector as D, which is pi and pi and pi, and check out for D. And if you just say B, if you are just asking R if B is equals to D, then you have false, true, false. That means R is doing just element-wise comparisons in here. And of course, you can always check for inequality in here. And B is not equal to D. And there are some places that is true. For example, for the first elements, that's true, they are not equal. But for the second ones, they are equal. Then this is not true and it is false. And for the third one, they are not equal and this is true because you're asking for if they are not equal to each other. And then as for B is smaller than D, true, false, false. You see, for the first element, yes, the first element of the B is smaller than D. And also you can just ask for B smaller and equals to D. You have true, true, false. It's just asking for the smaller and equal values for these two vectors, or just do the opposite in here, and greater than D, which is false, true, and true. Okay. You can also compare each element of the vector against a scalar in here. Let's say I have my B. I want to say if B, each element of B is equals to pi. This is false, true, true. Or I want to say if equals to 100. You have false, false, false. Okay. And also you may want to know whether any of the comparisons were true or whether all the comparisons were true in here. You can just use any and all functions in here. And I think the example will be more helpful to get the idea. Remember, I have my B vector, which 3 elements. If any of elements in B equals to pi. Do you know the answer? Do you know the answer in here? Any idea?
Is it true?
I think it would be true.
True.
It's supposed to be true since we have one element in B, which is pi. So, yes, any of the elements in here is pi. But also, if you ask for all elements in B equals pi, what is the result in here?
False.
Supposed to be false, because not all of them are pi. We have one, but the rest of them are not pi in here.
Hocam, I have a question. From what I understand, we can assign multiple variables to one variable. Is it right?
Yes, because that's why we call them vector.
Yeah.
If it is a vector, then that means it can include more than one variable. Okay. Thank you for the question. Do you have any more questions in here? So if not, let me move to sorting in these vectors. Say I want to generate a V vector by combining some values. Let's say 10 to 1. This is a sequence. I have 5, I have 2.2 and 3.5. I did something. Let's see. Here is my V. if you want to sort this guy, just use sort easily. And you will see that it's just having the smaller value and just sorting them. Okay. Of course, you can always sort them in a decreasing format. Let's say I want to sort V, and there's an option in sort, let's say decreasing. If you just say true in here, and your new sorted vector is decreasing in here. Okay. So we can always easily sort your vectors in R. And I want to show you something nice in here. Let's say we have this part. Can you see this part?
Yes.
Yeah.
Yes.
So far, what we have seen in here is that everything in R is an object. So R is an object-oriented programming tool in here. And we have 6 basic data types. And the character, numeric, it can be real or decimal in here. We have integer and logical, complex, and raw values. Okay. And if you want to see if your vector or your objects has any of these features, you can use class. And to see what kind of object is it, and I think we already used that part. And you can see the type of and length, how long is it? And you can just use dimension for 2-dimensional objects, and attributes. Does it have any metadata in here? You can just use attributes. And we will see some examples in R, depending on these guys. For example, I have my X, and let's say data mine, and R has that new variable. And if you want to see the class of that X, just write class and you will see it's a character. And also the type of this X is a character in here. And if you want to see the attributes, if we have any, for X, for example, X doesn't have any attributes in here. And when you generate another vector, let's say from 1 to 20, I have my Y, and I want to see the type of this Y, and you see it's an integer in here. And you can generate another object from Y. Let's say I have Z as numeric, sorry guys, as numeric in here. You are just converting Y from integer to numeric in here. Let's say this is my Z. And I can say if it's a type of, you will see this is a double in here. Okay. And also R has many data structures like atomic vectors, list, matrix, data frame, factors. And vector can be one of 2 types. They can be atomic vectors or list in here. But when we are talking about this R for atomic types, we are saying that this is vector, okay? We are not talking about list for our lectures. So far we saw some atomic vectors in here, and we will still list matrix, data frames, and factors later on, okay? And before closing this lecture, I want to show you some missing data structures.
Hocam type of Z neden double çıktı? Oraya kaçırdım ben. Tekrar eder misiniz?
So for class, maybe you are remembering that when we check out for class, we are seeing that what kind of object is this one? This is kind of a high level, okay? For example, when you check for Y, and when you say for class, this is an integer, and also the type is an integer. But when you change this Y as a numeric, if you are writing a numeric, like in Z, and when you check out for the Z, as a high level, Z is a numeric. But for the low level, this is a numeric, but as a data type, it's a double. Okay?
Tamam. Tamam. Teşekkür ederim.
Oh, sorry. Okay, before finishing the lecture, I want to show you the missing data types in here. Let's say I have my A vector from 1 to 3, NA, and 7. Here is my A. You see 1, 2, 3, NA, and 7. And I have one value which is missing. And also for B, I can combine true, false, NA, and false. And again, this vector has one NA value in here. So when you use isNA function, isNA, this function is just indicates the elements of the vector that represent missing data in here. And let's say isNA A. You will see it's just indicating some of your values are NA. For example, for A, the fourth one is NA, and true for this guy, okay? And if you just check out this is NA for, do I have any NA values in B? And yes, you have one value, which is NA in B, this guy, okay? And if you are looking for the function NA, any NA, which is going to return to true if the vector contains any missing values in here. For example, I have any NA for A, it is true because I have one value, which is NA. And also, you can ask the same question for B, and now it is true too. And also there is one value for missing data, which is infinity. And this may have either positive or negative infinity. Let's say I try 1/0. Do you know what is the meaning of 1/0 in math? It is infinity. When you just run this line, R is giving you infinity in here. Okay? And do you remember what was 0/0 in math? Huh? Do you have any idea what was 0/0?
Undefined.
Undefined.
This is an undefined value. That means this is not a number. And when you just run this part, you see R is giving you NaN. That means this is not a number. And this is another way for missing values. You may have NA values, some infinities, and NaN values, not a number values, okay? So this is all I wanted to say about missing data in here.